Welcome back. Today we are doing 10.3 combinations of functions. Like last section on 9.3, today we are also going to be using textbook functions, modeling change, a preparation for calculus, 4th edition for today's lesson due to too much information that is hard for me to summarize. So with no further ado, let us get started. Okay, so to start off, we're doing the difference of two functions defined by formulas, basically a measure of property. So if we have pt equals 2 times 1.04 to the t and nt equals 4 plus 0.5 t, then how do we find the differences of these? So first, if we put the difference as st, it's basically asking number of people that can be fed, which is nt, minus number of people living in the country, which is pt. So like this says here, st is going to equal nt minus pt. So how do we do that? It's basically just basic calculations. So if we put this, and put the values into nt and pt, st is going to be this. And if we graph our results, we're going to get this graph here with a spot just around here, and the surplus as a function of time is going to be here as well. So we know that our result is going to be around at time t equals 78.320. Not hard at all. Okay, moving on. Now what we're going to do is factor a function's formula into a product. So what this means is basically finding exactly all the zeros of the function. So let's say we have a function that's px equals 2x times 6x squared minus 2x times 6 minus 2 to the x plus 1 power. Wow, that is very long. Okay, it's not that hard. What we're going to do is we're just basically factoring. This is actually what we've been doing in middle school as well. So if you just know the ways, it's not that hard. So if we rewrite the formula, we're going to pull out 2x and then factor it with that. And if we factor the quadratic, this is basically what we're going to get. It's really not that hard. And if we use the linear factors to 0, we're going to get x equals negative half and x equals 2 over 3. So factoring a function's formula is really not that hard if you just take a look at it and know what to factor out. So moving on, we have now the quotient of functions defined by formulas and graphs. Prosperity. Okay, so now let's think of RT as number of people that can be fed over the number of people living in the country. So now we're doing NT over PT. So what that gives us is basically around 3.1, which is meaning that in year 20... Oh, my bad. So if the year is 25, we're going to get 3.1, which is meaning that in year 25, everybody in the country could on average have more than 3 times as much as food he or she needs. So this is going to be the formula for RT. So if we know either T, we can put it in and know the year, know how many times, or if we know how many times, we can find the year. So it's kind of like given back situation here. If we define this by tables, it's just basically putting in certain number of years and then finding that value since then for A and B. So if we do that, we're going to get these values after putting the values into the function that we made and factor it out. So this is kind of an example they've given us here. If RA T is the number of crimes in year T, number of people in year T, and if this is our equation and we put in certain value here, like we have 2005, 6, 7, like 1, 2, 3, 4, 5 since 2000, then we can basically find RA of T. So what they did here was put in 2006, which is 1 year since 2005. So they put in 1 and they found the value, which is 0.0128 crimes per person. So if we just know the the function we have and we know what value to put in t, it's really not that hard to find this value here, which was RA, or crimes, how many crimes per person. So if you just put that in mind, 10.3 isn't really going to be easy. Like I said, we did factoring out the zeros and the functions through graphs and through tables here. So just keep that in mind, and I guarantee you will not have a hard time with this. Okay, till next time.